Little fast classes. Now, today we are going to discuss. Gas laws. Okay, gas laws. Now see here. Yesterday we discussed what is gas law. Gas law means the gas has four measurable properties. The gas has four measurable properties. So among the four properties, any two, okay, any two properties are always kept constant, and relation between any two properties is discussed. This is known as gas law because this relation explains you the behavior, okay, the behavior of gas. Okay, to understand the nature of gas, certain laws are proposed which are called as gas laws, and these gas laws based on the four measurable properties. And the four measurable properties are mass of the gas given in a number of moles, or sometimes gram and kg also based on calculation. Then temperature, Celsius or in Kelvin. Next, pressure. Okay, atmosphere, bar, tar, c. Okay, centimeters, millimeters, pascals, kilopascals, Newton per meter square. Okay, or dynes per centimeter square, like that. And the next is volume. The volume means the 3D space occupied by gas. That is centimeter cube, which is equal to milliliter, which is equal to cc, and 1000 ml equal to 1 liter. Okay, and the 1 liter equal to 1 decimeter cube, as 1 decimeter equal to 10 centimeters. So cube of 10 centimeter cube is 1 decimeter cube, which is equal to 1 liter. This is what we have discussed in the previous class. So now we'll see the one by one some gas laws. Okay, కొంచెం fast గా చెప్పుకోవాల్సి వస్తుంది because we don't have much time. So take the first law. So in the every gas law, the four are involved, but always the two will be kept constant, the other two will be related. Say the very first one. Okay, the very first one is Boyle's law. The very first one is Boyle's law. Okay, it is proposed by Robert Boyle. So all these are based on observations. So at constant temperature, means temperature is constant for a given mass of gas. Means mass also constant. The pressure and volume of the gas are inversely proportional to each other. The pressure and volume of the gas are inversely proportional to each other. Means if the pressure is more, means volume is less. If the pressure is less, volume is more. Okay, so this relation is called Boyle's law. Okay, so here say this can be written as PV is equals to, or you can write PV. Okay, now PV is a product is equals to, PV is, I'll write instead P. If I remove this proportionality sign, I have to write a proportionality constant. So that is what K by V. Okay, where V is volume. Then we can write as PV is equals to K, where K is constant. So previously, how we define? At a constant temperature for a given mass of gas, the pressure and volume of the gas are inversely proportional to each other. At the same time, you can define as the product of pressure and volume. Okay, PV means pressure and volume product multiplied. The product of pressure and volume of the gas. The pressure and volume of the gas is a constant at a given temperature and for a given mass of gas is known as Boyle's law. Okay, so this can be written as, further This can be written as say P1 V1 equal to P2 V2. One more form of Boyle's law. Okay, it is first law. So here say for this I will explain. Suppose a gas is taken. A gas is taken in a container. In a container which is closed. And this container, okay, in the container we have gas and say the gas volume is V1. Okay, it is having the volume of V1 and the gas in the container is fitted with a cap or lid and this lid is frictionless. This frictionless means easily moving up and down like in injection. Okay, the syringe, okay, in syringe how it will move easily. So such lid is called as frictionless. Okay, frictionless easily moving lid is there. Okay, it is called piston. It's called as piston and this gas is offering certain pressure P1 and we know how the gases offer pressure due to collision made on the walls of container. Walls of a container. Now this gas is having volume V1 and pressure P1. Suppose if you increase the pressure, you know that pressure is the force per area. Pressure is force per area. So suppose if you put some weight, weights on this cap, okay, or lid. The lid offers the surface area and this weight offers the force. So this force per area is the additional pressure. So when you put some weights on this lid, what happens? Due to kept weight, some force is on this surface area of lid. So this force per area is called as pressure. So now pressure is increased from Hare Krishna. Vamshi Krishna, check an answer. The pressure is increased because additional pressure is existing there, P. So pressure is increased from P1 to P2. Therefore, what happens? The piston is pulled downwards. The piston will come down. Okay. So at this condition, the pressure is P2. The pressure is increased. And what about volume? Totally before this up to blue mark is V1. As pressure is increased to P1, P2, the volume is decreased to V2. See here, now here the volume is this much only, whereas in previous case V1, okay, this blue height. Okay, so what happened? As pressure increased, volume decreases. Means both are inversely proportional to each other. It is called as Boyle's law. It is what nature of gas. When pressure increases, volume decreases. So by increasing pressure only, the gases are filled in cylinders, containers. And when the gas is coming out of the container, cylinder, outside pressure is less. So gases have tendency, behavior to expand from high pressure to low pressure. So Boyle's law explains what is that? Isothermal. Listen carefully. Isothermal expansion of gas. Isothermal compression of gas. Because here the temperature is taken constant. So any gas expansion or compression is studied according to Boyle's law. Means the temperature is constant. The change in temperature is 0. Such process called as isothermal process. Understand? So any work or any process involves the Boyle's law. Pressure volume work at constant temperature is called isothermal process. Okay, and if you plot the graphs, okay, if you plot the graphs for the pressure and volume, the graph also called as isotherm. Okay, so now we'll have the graph. For the pressure and volume according to Boyle's law. Okay, so see here along this, okay, along this y-axis, I'm taking volume. You can take pressure also. Next, along the x-axis, I'm taking the pressure. You can take pressure and volume. You can change it. Okay, we need concept. See beta, just to see this graph. Once you see this graph and understand, you can understand any graph. See, here the temperature is constant. Change in temperature is 0. Delta T stands for the 0. Means no change in temperature, isothermal process. Okay. Now, here if you see 0 to this direct indicates increase in pressure. Increase in pressure. So 0, 1, 2, 3, 4, 5, 6, 7. Pressure is increasing. Then here it is volume. 1, 2, 3, 4, 5, 6, 7, 8, 9, like that going on. Volume is increasing. Okay. Now tell me what this point indicates beta? Pressure high or low? What is this point indicates? Pressure low or high beta? Tell me what is this point indicates? ఈ పాయింట్ ఏం చెప్తుంది బేటా? This point on this x-axis, pressure axis, indicates low pressure or high pressure. It indicates low pressure because lower value. Where another point, if you take this point, it is high pressure. Okay, this indicates high pressure, and here it is low pressure. Okay, so now compare the volumes. Okay, compare the volume according to Boyle's law. At low pressure, volume is more. So here at this point, I have to show the higher volume. See, for volume, this point indicates a low volume, and this point indicates a high volume. Okay, so at low pressure, volume is more, and at high pressure, volume is less. Understand? Then connect them. You'll get a graph like this. What is the shape of this graph? Yes, rectangular hyperbola. So here the graph indicates pressure is low, volume is more. Okay, then pressure is high, volume is less. And this graph is called as isotherm. It is called as isotherm. Is that clear? Then you can plot one more graph. You can plot one more graph also. You can draw many graphs if you understand the concept. I'm taking here. This time I'm taking here volume on the, once again same, on the y-axis, same, the volume is increasing. Volume is increasing. Or say I will take this time pressure, your wish. And along this x-axis I will take here 1 by P. 1 by V, because they have taken the P. Now see, according to Boyle's law, see beta, pressure is inversely proportional to volume, or pressure and volume are inversely proportional to each other. So here P is taken along the y-axis and 1 by V along the x-axis. See here, the pressure and volume are inversely proportional, but 1 by V is directly proportional. So as P increases, 1 by V increases. Is that clear? Is that clear? Pressure and volume are inversely proportional. Pressure increases, volume decreases. This graph. But here the pressure is directly proportional to reciprocal of volume. So pressure increases, reciprocal of volume increases. So for this, the graph will be, what is that? A straight line. A straight line. Understand? A straight line. Okay. So here pressure is 0. 1 by V is 0. Then P increases. Slowly P increases. 1 by V increases. You have to understand inversely proportional proportionality relations. Okay. Inversely means one increase, other decrease. Proportional means both increases. Both increases. Okay. And next graph. See here also the graph is between pressure and volume only. Still it is also called isotherm. Isotherm. Okay. Then we'll go for one more. What is the PV product according to Boyle's law beta? Is PV equal to K. So what is the meaning of K? K is a constant. K is a constant. So means you can plot here. The PV versus P. Okay, PV versus P. So at any pressure, the PV is constant. Therefore, you get a straight line which is parallel to x-axis. In the same way, you can draw a graph for PV versus V. At any volume, since PV is constant, so what is that? You will get a horizontal line that is parallel to x-axis. So these are different graphs, and you can take even log also. Okay, this is Boyle's law. Next, in the same way, we have Charles' law and Gay-Lussac's law, Avogadro's law. Okay. So for that, I will send you some more videos. Now, see here. Okay. I will tell you 3 gas laws at one place. See here. Boyle's law. According to Boyle's law, what is that? PV is constant. PV is constant. That is, pressure and volume are inversely proportional to each other at constant temperature. And next, here, one more. According to Charles' law, the volume, okay, V by T is constant. V by T is constant. Means the volume of gas is directly proportional to absolute temperature. In yesterday's class, we have learned that as temperature of the gas increases, volume increases, because as temperature increases means the heat of the gas molecules increases. Kinetic energy increases. Therefore, collisions increases. Therefore, gases try to expand. Therefore, volume increases. Then take one more gas law. That is Gay-Lussac's law. Okay, Charles Gay-Lussac's law. Okay, where according to this, pressure by temperature, the P by T is constant. Means here in Boyle's law, out of the 4 measurable properties, pressure and volume, okay, pressure and volume are related, and temperature and mass are kept constant. So the Boyle's law is isothermal process. And according to Charles' law, volume and temperature are related. So what is that kept constant? Pressure and mass is kept constant. So any process which follows the Charles' law at constant pressure is called as isobaric process. Where delta P will be 0. And here in the Gay-Lussac's law, pressure and temperature are measured. Means what is that? Volume and mass is kept constant. When volume is kept constant, the process is called as isochoric process. Okay, isochoric process where volume change is 0 at constant volume. Okay, so here, so in Boyle's law, P, pressure inversely proportional to volume. In Charles' law, volume and absolute temperature are directly proportional to each other. And in Gay-Lussac's law, pressure is directly proportional to temperature. Because we know that the gases offer pressure due to collisions made on the walls of container. As temperature increases, the heat content of gas molecules increases. Kinetic energy increases, number of collisions increases. When they collide with walls of container, many times with much more kinetic energy, then collisions more increases, pressure more increases. Why I am taking this? Okay, I want first these 3. Okay, how to remember this? Now, I will tell you a small trick to remember. You make a triangle of this. Okay, you make a triangle of this. Okay, yes, I have taken a triangle and making it 3 parts. Could you see the triangle better? Please give me answer. I will explain you Avogadro's law later for P equals to nRT. Okay, could you see? Vamshi. Okay, now here I'll take you, see this one. Now at this corner I'm putting P. P for pressure. P for pressure. At this corner I'm putting V. V for volume. And here I'm putting T. T for temperature. Okay. Easy to remember these three laws. Now here, what is that law relating the? Tell me. What is that law relating the or related with pressure and volume? Boyle's law. B. Okay. Then what is that law relating the volume and temperature? Charles' law. C. Then what is that law relating the pressure and temperature? Gay-Lussac's law. Vachinda? Then see how these are present. P and V adjacent to each other. PV. PV is constant. Then below is temperature. Could you see there? So P by T, Gay-Lussac's law. V by T, Charles' law. PV, Boyle's law. Vachinda? Yes? Got it? Got it? Okay. If you make the triangle, and in this triangle, what is that? What is that? PV. Pressure and volume are inversely proportional to each other. Boyle's law. Here, V by T, Charles' law, directly proportional. Then P and T, Gay-Lussac's law. And this can be, okay, explained with or memorized with a mnemotic. Okay, mnemotic means some phrases, some words are used, okay, to remember easily. Okay, so this can be remembered as can these gas, okay, can these guys possibly be victorious? ఒక చిన్న సామెత లాగా ప్రోవర్బ్ లాగా గుర్తుపెట్టుకోండి. Can these guys possibly be victorious? Okay, to remember these three laws. Understand? Okay. Next, as you asked me, yes, madam, there is Avogadro's law also there. Okay, Avogadro's law is also there, and we know the ideal gas. What is ideal gas? The gas which obeys all the gas laws. Okay, all the gas laws. Okay, the gas which obeys all the gas laws. Boyle's law, Charles' law, Avogadro's law, Gay-Lussac's law. Okay, A law, B law, C law, D law. All laws at all the given temperatures and pressure conditions is called ideal. Means at any conditions, low temperature, high pressure, or high temperature, low pressure, it has to exist in gas state. But truly speaking, no gas is ideal. Okay, so when you want to prove the ideal gas, you have to do a lot of experiment with respect to Boyle's law, Charles' law, okay, Gay-Lussac's law, and what Avogadro's law. So you have to try different gas laws at different times. It takes a lot of time. In that case, do one thing. When you mix all these gas laws, what happens? When you mix all these gas laws, what you will get? Combined gas equation. Okay, combined gas equation. You will get combined gas equation, and that combined gas equation is called as PV is equals to nRT. PV is equals to nRT, which is known as combined gas equation or ideal gas equation. Ideal gas equation. So if you put this PV is equals to nRT and see different relation, it is the mixture of all the different gas laws. Okay, so you can derive this PV is equals to nRT by combination of any three laws. Okay, so for easy understanding, you have to consider Boyle's law, Charles' law. The third one is Avogadro's law. Okay, you can use Gay-Lussac's law also. Okay, because in this every law is present. So take Avogadro's law. Okay, take Avogadro's law. According to Avogadro's law, equal volumes of gases. Okay, equal volumes of gases have equal number of moles. Equal number of gases have equal volumes of gases have equal number of moles. Okay, so V is proportional to N. V is proportional to N. I'll write here. According to Avogadro's law, V is proportional to N. When the different gases are present in same, different containers of same volume, then the number of moles also will be same. I'll give you one example. Now for this, what we can write here, this is V by N. V by N. Okay, this is always constant. Okay, and when you okay, when you what it is combine them. Okay, now combine them. When you combine them, you get here. See, on combination, for sake of convenience, all are laws only. We can combine all this. Okay, so combine these all. Okay, combine these all and little change. Pressure is inversely proportional to volume. At the same time, volume also inversely proportional to pressure. Volume also inversely proportional to pressure. So, can I write here in place of P? Okay, in place of V. Okay, here I'll change it. P and this is a V because according to Boyle's law, pressure and volume are inversely proportional to each other. So combine all these gas laws. Okay, mix Boyle's law with Charles' law with Avogadro's law. Mix all these. So what you get? V. V is equals to V. V proportional to 1 by P. P proportional to T. P proportional to N. So V proportional to, see here, N T by P. Yes or not? Yes or not? Yes. Okay. Then we can write as this. Bring this P there. PV proportional to NT. Then I don't want to see this proportionality sign. Replace with a constant. Generally, what constant we use? Generally, we use K. This time, some variety. Okay. This time, we'll use some variety constant. What is your chemistry madam name? What is your chemistry madam name? Na parenti. I hope you know my name. So use my name first letter. What is that? What is that? R. Capital R. So generally we use for proportionality constant K. This time we'll use R. Okay. The R is what? Universal gas constant. R is universal gas constant. R, it is a gas constant whose value is same for all the gases. Okay. Whether it is ideal gas or non-ideal. For all the gases its value is same and applicable to 1 mole of gas. So hence it is called as molar gas constant or universal gas constant or gas constant. So now this time we replace this proportional sign with R. Okay, ఇప్పుడు చూడండి రూపా మేడం వచ్చింది ఆర్ వచ్చింది ఇప్పుడు మీ ఫేవరెట్ స్టార్ కూడా వస్తాడు ఓకే who is that I'll write here see here tell me who is there PV is equals to I replace this proportional sign with equal to I'm putting R NT R అరే ఎవరు వచ్చారు who came there ఎవరు వచ్చారు PV equal to NTR. Is that clear? PV equal to NTR, nothing but nRT. So your favorite star or not? Yes, of course. Everyone likes the NTR. I like much because he is the only one guy. Okay? He is having all the. Okay? So this is what simply can be written as PV is equals to PV is equals to nRT. PV is equals to nRT. Where R is gas constant. Means R value for any gas, its value is constant. So when you write, see here, for any 1 mole of gas, N is number of moles. For any 1 mole of gas, N equal to 1. Then what happens? PV is equals to RT. PV is equals to RT. Then you can write as PV by T is equals to R. Means R is constant. So therefore, what we can write? One more formula of ideal gas equation. This can be written as P1 V1 by T1 is equals to P2 V2 by T2. It is one more form of ideal gas equation. Is that clear? Yes. Okay. And next, so any gas which obeys PV is equals to nRT or P1 V1 by T1 equal to P2 V2 by T2 is said to be ideal. Then what is R? R is universal gas constant, not R for the Rupa. Okay, R is universal gas constant. Okay, then we'll see the units of R. The units of R. See beta, I'm not asking value. Value ఏముంది STP conditions చేస్తే వచ్చేస్తుంది. Units కావాలి first. Okay, we'll see the units of R. So next is R. Units of R. So PV is equals to nRT. Then speak with respect to, okay, units of R. So formula PV is equals to nRT. So now praise the R. R గురించి మాట్లాడదాం. So bring everything equal to R. So R equal to with the top in the PV by NT. So units of R will be equal to units of PV by units of NT. So what is that? Pressure is taken in atmosphere. Volume is taken in liter. Then number of moles N. Mole. And temperature in Kelvin. Is that clear? So what are the units of R? Liter, atmosphere, per mole, per Kelvin. అర్థమైందా? This will go up. So what is that? R can be expressed as liter. ముందు తీసుకోవచ్చు. Atmosphere. Then this mole goes up, becomes inverse. Per mole, per Kelvin. Is that clear? And next, we'll put the values. Now put the all the pressure, volume, okay, temperature, volume, okay, at STP conditions. STP means per 1 mole of gas. For 1 mole of gas, if n equal to 1, at STP, the pressure is, what is that pressure? 1 atmosphere. Then volume, 22.4 liters. Then, what is this? Number of moles is 1 mole. Number of moles is 1 mole. 1 mole into temperature at STP. At STP, what is that? 273 Kelvin. So what do you get here? Simply liter atmosphere per mole per Kelvin. This what you get? R equal to 1 get cancelled. Need not to worry. So what you get here? 22.4 divided by 273. 273 Kelvin. Okay, 273. This is what units of and value of R. And when you solve this, sometimes you can take this direct value. Okay, because easy to cancel. For 1 mole of gas, this much volume at STP. For 2 moles, 44.8. Easy calculation. And when you solve this, you will get here. This is 0.0821 liter atmosphere per mole per Kelvin. Okay, is that clear? And in ergs, okay, 8 point, do you remember in ergs and joules? Okay, I'll give you in joules. 8.314 joule liter atmosphere. 1 liter atmosphere equal to 100 joules. Okay, so joule per mole per Kelvin. And I hope you know that the conversion of joule and erg. Okay, Planck's constant value in joules is 6.6256 10 power minus 34 joules seconds. Whereas in erg, 6.6256 10 power minus 27 ergs seconds. So difference is you put and tell me, send me the answer. Understand? So please watch the video number of times today. Okay, and next, you know that 1 liter equal to 1000 cc, 1000 ml. Okay, 1 liter equal to 1000 cc. So also give me the answer in WhatsApp, the value, this 0.0821, which is liter atmosphere per mole per Kelvin in cc, by using this 1 liter equal to 1000 cc. So please give me answer. Okay, anni nene chepte ela, you send me answer in the WhatsApp. Okay, thank you. I will send the video now.